Hello, welcome to section 4.7, the quadratic formula. The quadratic formula is a formula which will solve all quadratics. Here it is, and it's going to look intimidating, but we're going to split it up into two parts. We're going to use some colors here to help us. I have green. That doesn't really look like green. I have brown, and I have blue. That probably looks like black, and that also looks like black. So we'll do the best we can here to do that. I have highlighters. We'll make this all nice and pretty. So right now I'm writing in brown. It is fall. So the quadratic formula is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Now there's a couple things that you should notice about this right away. This should look familiar, negative b over 2a. That's the h, the x coordinate of the vertex. Also, you should notice the plus or minus. The plus or minus means that there's two solutions to these, which we've been looking for a while now. When this part is 0, then it really is just the vertex. The solution is the vertex, which means there's only one solution. The parabola is touching the x-axis in one location. So when this part here is 0, then it really is the vertex. But there's some familiarity here. Where do we get our a, b, and c from? Well, what we've been talking about the whole time. When you have a quadratic in standard form, a goes with x squared, b goes with x, and c is the thing by itself. And we want our quadratics to be equal to 0. Hence, y is equal to 0. And when y is equal to 0, that means we are looking for where this parabola crosses the x-axis. So when y is 0, we're looking for the roots. We're looking for the x values that make the function 0. So we call those the zeros of the function, or the x-intercepts. And as you guys know, if we can name something in math 3 different ways, it must be pretty doggone important. Okay, before we start doing the quadratic formula, we're going to do a quick little review of simplifying radicals. So, simplifying radicals. So this is something that comes from past classes, maybe geometry, algebra 1. Square root of 50 does not work out so well. So we can break this up into what we can take the square root of and what we can't take the square root of. We can factor this into two things. Now factoring it into 5 and 10 won't do any good. So in pencil I'll write 5 and 10, and I can't take the square root of 5 or square root of 10 either. So that's a dead-end situation. But we want to be smart about factoring 50. So I'll erase this. And I will factor it into 25 and 2. So why did I do that? Because I've just made this part a perfect square, and this part's not a perfect square. So I can now take the square root of this, and I get 5 radical 2. So this part here is 5, and then radical 2. So these are equivalent statements. Square root of 50 and then 5 radical 2 are the same thing, and this is considered simplest radical form. If you don't believe me, type the two things into the calculator, and they will be the same answer. Let's do another one. Square root of 27. There's only, besides 1 and 27, just 9 and 3 makes the 27. So square root of 9, square root of 3. Yes, I can take the square root of this. No. So I get 3 radical 3. And that's considered simplest radical form. One more. Square root of 28. Notice these are one number apart from each other, but they have completely different factors, and will look different at the end. 2 and 14 doesn't really work either, does it? Because you have to have a perfect square situation here. So 4 comes to mind, and 4 times 7. So it becomes 2 radical 7. All right, we'll need this when we do some of our quadratic formula things. So here's the quadratic formula. Negative b plus or minus square root of b squared minus 4ac all over 2a. This formula is not a mystery. It comes from completing the square, and I have a whole video just showing you where the quadratic formula comes from. All right, let's do an example. Example 1. x squared plus 4x minus 3 equals 0. Now, if this was positive here, it would factor, because I could do 3 and 1, and then the 3 and 1 would add together to make 4. But with this negative here, this does not factor, so I need a way to do this. I could complete the square. This would be a really nice one to complete the square, and since that's an even number. But the quadratic formula is the lesson for today. So the first thing you do is you identify A, which is 1, B, which is 4, and C, take the negative with it, negative 3. Then we just plug these numbers into the formula. X equals negative B plus or minus the square root B squared minus 4AC all over 2A. And the part underneath here, we kind of separate this out. I have a green highlighter. That's what I typically do. I make this green when I do this on the smartboard. So we're going to separate this out and make it kind of a separate calculation. So basically, negative b over 2a you're used to doing, plus or minus, you write it down, square root, and then really the only thing you're calculating is this b squared minus 4ac, which you just use these numbers here and plug them in. So here we go. X equals 4, plug it in, negative 4 plus or minus square root all over 2a, so 2a to be 2 times 1. Now we do the b squared minus 4ac. I'm going to use green. So let's see, b squared would be 4 squared minus 4a, which is 1, and c, which is negative 3. And this is what has to be calculated. I'm going to pause it for a second here. Alright, I flipped the other set of lights on in my room. Maybe we can see that this is green and this is brown better. X equals negative 4 plus or minus square root over 2. So now we have to calculate this part right here. B squared minus 4 times a times c. Well, there's a negative times a negative. That's positive times 1. So all this part's 12. And then this would be 16. So it's 12 and 16 added together, because that's a negative times negative. So this part right here is equal to 28, because that's 12 and 16. So 28 comes down here. Now, what typically I do is I use a red pen to split up and take out the radicals. Now I'm looking for my red pen, which has disappeared on me. Okay, so I got to pause it again. Okay, so we're going to split 28 up into two things. Here we can see that that's red. I always use red for this. And I just did this on the other example, 4 and 7, 4 times 7. Now, we're going to put this all together. X is equal to negative 4 plus or minus 2 radical 7 over 2. Now I notice that this part right here is even, this is even, and that's even. So when all of these are even, or all of them are multiples of 3 or 5 or whatever, you can divide. So I can divide 2 into each one of these. So I'm like distributing the division. So I'm dividing 2 into here, dividing 2 into there. So my final answer is negative 2 plus or minus square root of 7. And that's what x is. So we started off with the equation. We found the a, b, and c. We plugged it in the formula. Really, this green part here is the main calculation, where I had 16 plus 12. 16 plus 12 is 28. And then this is considered the simplest form right here, where you get it all down and get the common factor taken out of those three numbers that I highlighted in yellow. All right, next example. Example 2 is 2x squared minus 6x minus 9 equals 0. This again will not factor. Notice a couple of things difference. A is not 1. And there's a negative here instead of a positive. So we have A is equal to 2, B is equal to negative 6, and C is equal to negative 9. And you guessed it, when we do negative b plus or minus the square root of b squared minus 4ac all over 2a, we have a negative and then b is negative. So it's just like when we found the vertex of the parabola, the negative b over 2a. It's a double negative situation. So we got 6 plus or minus square root over 2a would be 2 times 2 this time. Now I'm putting the discriminant. Oh, have I not called it the discriminant yet? This part underneath here is called the discriminant. We're going to talk about that in a second. So it's b squared to be negative 6. Make sure if you're going to use a calculator, you put that in parentheses so that it squares the negative. B squared minus 4 times a, which is 2, times c, which is negative 9. All right. Now we have to figure out what this is. That squared is 36. And then a negative times a negative is positive. So this would also be 36 if I multiply those two together, and then doubled would be 72. So 72. And if you add those together, this thing underneath here would be 108. All right, so I'm going to rewrite it again, put a 108 there. Really, again, this is the only thing I'm calculating is just this green part underneath here. The rest of it's just the structure of it, basically. So x is equal to 6 plus or minus the square root of 108 over 4. All right, now 108. I have my red pen here, and I'm going to separate 108. 108, it would be the square root of something, the square root of something. Well, I know that 36 lives in there because that's 36 plus 36 plus 36 makes the 108. So I know that it's 36 and 3. 36 and 3. So then I get brown pen. Where'd you go? Here you are. 6 plus or minus 6 radical 3 over 2. And then I notice again that these are all, oh, not over 2. I got ahead of myself. Over 4. So now I need my little correction ink here. I got ahead of myself. I knew this reduced down, so I got ahead of myself. Start fixing this. So it's over 4. 4 came over here, 6. Okay, now these are all even numbers. So they all have a 2 in common, and that's the most thing they have in common. So I can divide everything that I highlight in yellow by 2. And I get 3 plus or minus 3 radical 3 over 2. And that's the answer. So it's this thing plus this and this thing minus this, all, and then you cut it in half. Okay, now we're going to talk about the green thing underneath the square root sign there. It's called the discriminant. So b squared minus 4ac is called the discriminant. I have to concentrate here so I don't misspell it. So what that is to discriminate is to separate. So if you separate out the kinds of solutions, the discriminant does that for you. It's a separator. It tells you what kind of solutions you're going to get. Usually the word discriminate has a negative connotation to it, but in math, that's what it's called, the discriminant. So we're going to make a little table here. And do the discriminant. I'm going to abbreviate it, disc, for discriminant. And number of solutions. And graph. So the discriminant every time has been a positive number. So in the first example it was 28, in the next example it was 108. So the discriminant so far has been positive. So the b squared minus 4ac can be positive, which means greater than or equal to 0. So when that happens, there are two solutions. There are two real solutions. And the graph could look something like this. Right? The parabola touches in two locations. It can be a sad parabola too. So either kind of parabola. but it's going to touch the x-axis in two locations. So it could be a parabola that's happy or a parabola that's sad, but you get two solutions. So the discriminant can be other numbers too, because there are other numbers in the world, aren't there? So b squared minus 4ac could be 0. So when it's 0, then this part here cancels out. So all you're left with is negative b over the 2a. So you just get one solution. You just get the negative b over 2, because all of this is going to be 0. So you just get negative b over 2a. So you get one real solution. And what does that look like? That looks like this kind of situation where it comes down and touches the x-axis in one location, and we call that tangent. It's tangent to the x-axis. Or again, it could be a sad parabola. It could be an upside down parabola touching the x-axis at one point. All right, so there's one real solution. Now, there are other numbers between positive and negative, and that's right. The discriminant could be negative. B squared minus 4ac is negative, so b less than 0. So what that means graphically is the fact that the parabola doesn't touch or interact with the x-axis at all. So it could be a happy or sad parabola, but it doesn't touch the x-axis. So that means there are no real solutions. So if there's no real solutions, what kind of solutions do we call those? Well, we call those imaginary solutions. And that's what we learn about in the next section. But there's no real solutions. There's two. We call them two complex solutions. All right. Uh-oh. Looks like the brown pen has had it. Yep, the brown pen's had it. Well, it made it through the lesson. Anyway, so what we do is we have the formula. We plug numbers into the formula. We follow the order of operations in order to find the zeros of the function. Make sure you're in standard form with your quadratic set equal to 0. If it's not set equal to 0, you can't do the quadratic formula. All right, peace out.